Watch what happens when I shine light on this one. And then this one. Hey guys, in this video I'll show you how to toggle the LED on and off with light. Stay tuned to the second part of this video where I'll explain how this circuit works. I've packed my favorite 555 timer projects into a free ebook. Yep, totally free. Don't miss it. Click the link in the description to get yours. Here are all the components you need to set up this circuit. 7 jumper wires, 1 red LED, 2 10 kilo ohm resistors, 1 390 ohm resistor, a 9-volt battery buckle connector, a 9-volt battery, 1 555 timer IC, 2 LDR or light-dependent resistors, a breadboard to connect everything together. The 555 timer IC comes with 8 pins. There is a notch or a dot on the chip's body. Pin 1, located at the top left, serves as the ground or ground supply. Pin 2 is trigger. It is used to start the timing interval in both monostable and stable modes. Pin 3 is output. It delivers the result of the timer's operation based on its mode, either monostable, astable, or bistable. Pin 4 is reset. It is used to reset the 555 timer's internal flip-flop. Pin 5 is control. It allows you to control the threshold voltage levels that the internal comparators use to set and reset the flip-flop. Pin 6 is threshold. It monitors the voltage of the capacitor connected to the circuit. Pin 7 is discharge. It controls the charge and discharge cycle of the timing capacitor. Pin 8 is VCC. It is responsible for supplying the power to the IC. Let's set up the circuit step by step. Begin by positioning the 555 timer IC on the breadboard. The pins are numbered counterclockwise, starting from the top left corner. Refer to the later circuit diagram if you have questions about the circuit connections. Insert the 555 timer in the middle of the breadboard. A jumper wire connects pin 1 or ground to the negative rail. A jumper wire connects pin 8 or VCC to the positive rail. Use a jumper wire to connect pin 4 or reset to pin 8 or VCC. Insert a jumper wire into pin 2 or trigger in a few rows above the 555. Insert an LDR or light-dependent resistor into the same row as the jumper wire and the negative rail. Bend the ends of a 10 kilo ohm resistor. Insert a 10 kilo ohm resistor into pin 2 or trigger in the positive rail. Insert a jumper wire into pin 6 or threshold in a few rows below the 555. Insert an LDR into the same row as the jumper wire and the positive rail. Bend the ends of a 10 kilo ohm resistor. Insert a 10 kilo ohm resistor into pin 6 or threshold in the negative rail. Bend the ends of a 390 ohm resistor. Insert a 390 ohm resistor into pin 3 or output in a few rows below the 555. Insert a red LED in the same row as the resistor and the negative rail. The cathode is in the negative rail. Connect both ends of the negative rails with a jumper wire. Connect both ends of the positive rails with a jumper wire. Connect the 9-volt battery buckle connector to the 9-volt battery. Insert the positive lead to the positive rail. Insert the negative lead to the negative rail. I'm going to shine a flashlight on the left LDR and you'll see the red LED turn on. Now I'll move the flashlight to the right LDR and the red LED immediately turns off. To adjust the sensitivity, you can replace the 10 kilo ohm resistor with a potentiometer. Here, I've swapped the fixed 10 kilo ohm resistor for a 50 kilo ohm potentiometer. When the potentiometer is set to about 10 kilo ohms, only a small amount of light is enough to trigger the LED and turn it on. As I increase the resistance, the circuit becomes less sensitive and it takes more and more light before the LED finally turns on. Let's dive into the circuit and break it down step by step. This circuit uses the 555 timer as a bistable latch. The 555 has two internal comparators that watch two key pins, pin 2 or trigger and pin 6 or threshold. If pin 2 is pulled below about 1/3 of VCC, the 555 sets and pin 3 or output goes high and stays high even after pin 2 returns back up. If pin 6 is pushed above about 2/3 of VCC, the 555 resets and the output goes low and stays low even after pin 6 falls back down. That stays there, behavior is the important part. Once you hit the on condition, it remembers on until you hit the off condition. R1 and the LDR form a voltage divider feeding pin 2 or trigger. R1 pulls that node up toward the 9-volt battery while the LDR pulls it down toward ground, depending on light. When you shine light on the LDR, its resistance drops, so the divider pulls the trigger node lower. If it drops low enough, below 1/3 VCC, the 555 sets internally and the output snaps high. When you remove the light, the trigger node rises again, but the output stays high because the latch is already set. R4 and the LDR form another divider feeding pin 6 or threshold. Here, R4 pulls the node down toward ground, and the LDR pulls it up toward the 9-volt battery when it's illuminated, because the LDR resistance falls and it becomes a stronger connection to VCC. When you shine light on the LDR, the threshold node rises. If it rises above 2/3 VCC, the 555 resets and the output drops low. After that, even if the light is removed and the node falls again, the output stays low until the trigger input is forced low again by the LDR. The LED on the output is just an indicator of the latch state. R5 limits the LED current, and the LED is wired from the output through R5 down to ground. When pin 3 goes high, current flows and the LED turns on. When pin 3 goes low, it turns off. Pin 4 or reset is tied to VCC, so the chip is always enabled. Pin 7 or discharge isn't used here because this isn't a timing oscillator circuit. In practical terms, you're using two separate light sensors like two buttons. Shine light on the LDR to pull pin 2 low and latch the output on. Shine light on the LDR to push pin 6 high and latch the output off. I hope this video has shown you how to make a light toggle on and off with a 555 timer IC. Want to dive deeper into 555 timer projects? Grab my free ebook packed with awesome circuits and ideas. Just click the link in the description to download your copy now. If you found this video helpful, give it a thumbs up, consider subscribing for more electronics tips and tutorials, and hit the bell icon to never miss an update. Thanks for watching, and I'll see you in the next video.